Today let us do few more questions from Miscellaneous chapter 5. We have already completed up to question number 12. So now today let us start from question number 12. So your question number 12 is find dy dx if y is equal to 12 within bracket 1 minus cos t comma x equal to 10 within bracket t minus sin t. You have to find out here dy dx, x and y are given, y and x are given. You see, from the question we understand that x and y, these are parametric functions because x is a function of t and y is a function of t. They are directly not related. So we have to use here parametric differentiation. That's why we have first considered y, that is 12 into 1 minus cos t, and since t is the parameter, so we take the differentiation of y with respect to t. That is ddt of y, which is equal to 12 is a constant, come out ddt of 1 minus cos t. On taking differentiation, 12 is as it is, ddt of t is 0 and minus ddt of cos t is minus sin t. So the result is plus sin t. That means we got it 12 sin t. Then I just take the differentiation of this x with respect to t. That is equal to ddt of 10 t minus sin t. 10 is a constant, taking outside ddt of t is 1 and ddt of sin t is cos t. Okay, so here it is completed. After this, as our aim is to find out dy dx by parametric function, we know it, dy dx equal to what? dy dt by dx dt. Put the value of dy dt, that is equal to what? 12 by 12 sin t, and dx dt is 10 into 1 minus cos t. These are cancelled out, by 2 we can cancel, that is equal to what? 6 by 5 sin t minus 1 minus cos t. Then here you see, you can stop the solution here, but as we can simplify this further, so I have done the simplification. That is 1 minus cos t equal to what? 2 sin square t by 2. And sin t can be written as 2 by 2 sin t by t cos t by t. Because by the formula sin of a. Sin twice a, that is a multiple angle formula. So this is 6 by 5. And after that it is what? Sin and sin will be cancelled out. Cos t by sin t will be left. And cos t by 2 by sin t by 2 will be equal to what? 6 by 5 cot t by 2. So this is your answer. Here question number 12 is completed. Now let us go to question number 13. Your question number 13 is find dy dx. Y is equal to sin inverse of x plus sin inverse of 1 minus x square. So you see, directly we can take the differentiation of this result by using u plus v rule and then by applying that is sine rule. But in that way the question is be little bit lengthy. That's why I have used here trigonometric substitution for the second part. For that purpose, I just named it is already given as y is as written as. Then I just name it as u and v, where u is equal to sin inverse of x and v is equal to sin inverse of 1 minus x square. You see, you can do it directly also. And after taking derivative, ddx of y equal to ddx of u plus ddx of v. So our aim is to find out now ddx of u and ddx of v. So u is sin inverse of x. So du dx equal to what? Sin inverse of x formula is a substitute directly. ddx of sin inverse of x is 1 by under root 1 minus x square. But here, v is sin inverse of under root 1 minus x square. So these can be further simplified by putting sin x or sin theta or cos theta. I have used here cos theta just to get sin theta here. So x equal to cos theta if I put, then theta will give you cos inverse of x. That put it here. Your v will be equal to v sin inverse of 1 minus cos square theta. Putting x equal to cos theta. Trigonometric substitution, you have to think yourself. Okay. So here 1 minus cos square theta is sin square theta, that is equal to sin theta, and sin inverse of sin theta is theta. And theta means what? Cos inverse of x. So substitutes. You see the v is simplified to this form. That is dv dx equal to what? ddx of cos inverse of x. And the value of ddx of cos inverse of x is minus 1 by 1 under root 1 minus x square. Now I just put the value of du dx and dv dx here in dy dx. So dy dx equal to what is du dx? Under root 1 minus x square. So dy dx equal to under root 1 minus 1 by under root 1 minus x square minus 1 by under root 1 minus x square. So the value is equal to 0. Question number 13 is completed here. Let us go to question number 14. So you see, your question number 14 is a proof that question. If x into under root of 1 plus y into under root of 1 plus x equal to 0, for minus 1 less than x less than 1, that is 1, it lies between minus 1 and 1, prove that dy dx equal to minus 1 by 1 plus x square. Okay, so here you see the answer, we don't require square root. So before doing differentiation, I just first do the Remember, all the questions can be done directly, but sometimes you see, if I do it directly, then the solution will be a little bit lengthy. That's why, just to avoid it, I had done here a other method. That is, I want to remove here square root, as the answer don't require square root. So first I write down the given thing, that is what? X under root of 1 plus y under root of 1 plus x. To remove the square root, I just bring one of the term to the right side, so that if I square it, the square root will be removed. And I just bring this to the right side. This is the way of doing the square root, removing the square root symbol. So squaring, we got x square. Here the square root will be removed, 1 plus y. Squaring this positive, y square into 1 plus x. Then I just open the bracket and then I go to factorize it, to simplify it. Opening the bracket, we get x square plus x square into y is equal to y square plus y square into x. I just bring all this to the left side and arrange it. X square minus y square, just to factorize, plus x square y minus y square x equal to 0. You see, this type of question sometimes actually you have to practice. If you want to do in short way, then you have to practice it. Okay. So here you see we can factorize it by using a square minus b square formula, which is x plus y into x minus y. Here I can take common xy, then xy, if I take common, it will give you x minus y. So x minus y will be now common. X minus y taking common, here x plus y plus xy will be left. Now you see, either we get it 0 or we get it 0. Either x minus y equal to 0 or x plus y plus under root of xy equal to, x plus y plus x into y equal to 0. Now you see, x minus y cannot be equal to 0. X minus y, if I consider it as equal to 0, x will be equal to 0. X will be equal to y, which doesn't satisfy 1. Because you see, if I put x equal to y, then we'll get x under root of 1 plus x under root of 1 plus x. That is 2 times of x into 1 plus x. Is it equal to 0? No. Because x lies between 1 and minus 1. Okay, so since it cannot be equal to 0, that's why you must have what? This is equal to 0. So from here, I just find out, your aim is to get dy dx. So I just find out what is y. From here, if I simplify, y taking common, y into 1 plus x equal to minus x. So y is equal to minus x by 1 by x. Then I take the derivative, dy dx. Dy dx equal to minus sign, I just take it outside, then u by v rule I have applied. So that is equal to denominator v whole square, that is equal to 1 plus x whole square. V dx of u minus u dx of v. So v is 1 plus x, dx of x minus x, dx of 1 plus x. Then doing simplification, minus is there, 1 plus x whole square, derivative of x is 1, x, and this will be equal to 1 plus 0. You put this bracket, okay. Now just open the bracket, 1 plus x minus x. 1 plus x minus x plus x cancel out. So here only 1 will be left, that is the answer is minus 1 by 1 plus x square, which is the solution. Okay, and this is proved. Hope you understand the method. You see, this question I have done the square just to remove the square root. And the question can be done directly also. Little bit lengthy in that case. Substitution you have to use. Now go to this question. I have done this question in 2 different ways. One by directly doing this solution, and here shown this solution, and other by just using different method. That is what you see. Your question is, if x minus a whole square plus y minus b whole square equal to c square for some c greater than 0, prove that 1 plus dy dx whole square to the power 3 by 2 by d2y dx2 is a constant independent of a and b. You have to show it that if this is the result given, then this is a constant, but the constant is independent of a and b. That means a and b not present in that constant. Okay, so write down your given things. Second derivative, up to second derivative we have to do. So x minus a whole square plus y minus b whole square equal to c square. I just mark it as 1 because I am going to use here. Okay, so differentiating with respect to x, we get ddx of x minus a whole square plus ddx of y minus b whole square is equal to ddx of c square. Directly also you may write down. Doing the differentiation, we get what? X to the power n formula I have used, n into x to the power n minus 1. So 2 into x minus a ddx of x minus a. Here also 2 into y minus b ddx of y minus b, and ddx of constant is 0 because a, b, c are constant. Then here we got 2 is, I just cancel out, x minus a into ddx of x is 1 and minus 0, so it is 1. Y minus b, 2 I have taken common and cancel out. This is dy ds because it will be equal to 0. Again I have differentiate it, and I mark it as number 2. Again differentiating, we get it ddx of this one plus ddx of this into this. Here I can do directly ddx of x is 1 and ddx of a is 0. But here I have to apply u into v rule. Instead of using dy dx, you may use here y1, y2, these symbols also. Okay, but as in the answer I need the dy dx, that's why I am using here dy dx symbol. So here it is first function, this is the second function. So first function, derivative of ddx of dy dx plus dy dx, that is the second function, ddx of y minus b. So here 1 is there, y minus b, this is ddx of dy dx equal to what? d2y dx2, because the second derivative. Okay, this is dy dx, again this is also dy dx minus 0, that is dy dx. So do the simplification, I just keep the term containing dy dx on the left. That is y minus b d2y dx2. On the right, what will have? This is dy dx whole square, and this is minus 1. I just bring it to the left side. So y minus b value we have got. It is equal to what? This term divided by d2y dx2. I just mark it as number 4. And when we put the value of y minus b in 2 here, I'll get the value of x minus a. So let us see what happened. X minus a, here I have substituted the value of y minus b. This is y minus b into dy dx. You see, I have substituted here, right? And after that, let us do the simplification. X minus a value we have got. And then what I have done, I just put the value of x minus a and y minus b in 1. 1 is your x minus a whole square plus y minus b whole square equal to c square. So x minus a whole square I have substituted, y minus b whole square I have substituted. This is equal to c square. Now you see denominator is same, d2y dx2 whole square. Here this one, 1 plus dy dx whole square. Here also 1 plus dy dx whole square. That is coming common. Here dy dx will be left and here 1 will be left. That means now we see this and this expressions are same. So we can write down it as 1 plus dy dx whole square to the power whole cube, right? And that is denominator d2y dx2 whole square. It is equal to c square. It should be c square, okay, not cube. Just make the correction. So here you see what is your c. Taking the square root, you will have what? This whole to the power 3 by 2, and this square will be removed. And you see c, this value, we have to find out the value of this, and this value we have got it plus minus c, which is a constant independent of a and b. The same question I had done in a different way also. Here also I have done the differentiation. Hope you understand it. 2 x to the power n formula, 2 x minus a ddx of x minus a, I have done it directly. 2 y minus b dy dx equal to 0. From here I have got the value of dy dx. What is dy dx? I just write down this on the 2 to cancel out, minus x minus a by y minus b. Then I take the value of d2y. That means directly we have find out dy dx and d2y dx2. d2y dx2, so u by v rule you have to apply, v square ddx of u means 1 minus u, that is x minus a ddx of this is equal to dy dx, right? And after that, to get d2y dx2, I just substitute the value of dy dx. dy dx is this much. Taking LCM, it become y minus b whole cube, and here we have to do the product square, that is y minus b whole square plus x minus a whole square. And you see this is nothing but your c square, because this is given here, this is equal to c square. So here I have substituted this is c square and y minus b whole cube. Then I have considered your given expression and put the value. Here you see this is equal to I have substituted the value of dy dx, that is equal to x minus a by y minus b whole square to the power 3 by 2, and this value is equal to square by y minus b whole cube. Then do the simplification step. Here I'm taking common, then this is y minus b whole square plus x minus a whole square, and this is again I can substitute c square whole to the power 3 by 2, c square by this one whole to the power 3 by 2. Then here 3 by 2 and this square can be cancelled out, that is what left, c cube by y minus b whole cube, and this is what again y minus, to take the reciprocal, y minus b whole cube by c square. This is cancelled out, minus c is left, which is a constant independent of a and b. You see, I had given this question by 2 ways. Most probably second method will be easier for you, so you can do directly that second method, that is find out dy dx and d2y dx2 and substitute these values in this equation, that is a given expression. Okay, now the next question. Here you see this type of question, if you do by inspection, if you check it first and then do the differentiation, that will be easy for you. Same case arise here also. If cos y equal to x cos of a plus y with cos a is plus minus 1, prove that dy dx equal to cos square a plus y by sin a. Here this is the given expression, cos y x d cos of a plus y. As I need here cos square a, so I just want to bring this to the denominator. That means I can write down x equal to, I just bring it to the left side, that is what, cos y divided by cos of a plus y. Then I just take derivative on both sides, ddx of x equal to ddx of this expression. On the right side you see directly x the whole square will come, cos of a plus y whole square. This is v, and ddx of u minus u ddx of v formula I have used. Then I just take the square, that is cos square a plus y. Here this cos y derivative is minus sin y into dy dx, minus this one is cos y, and it is minus sin y, so minus minus plus, and dy dx will be there. Dy dx taking common, what is left, sin of positive term I have written first, sin of a plus y minus into cos of y minus cos of a plus y into sin of y. And this is nothing but the formula sin a cos b minus cos a sin b, that is sin of a minus b, which is sin of a plus y minus y. Plus y minus y cancel out, so sin a will be there. Then I just bring to the Sign it to the left side, that is dy dx equal to what? Cos square a plus y divided by sin a, which is proved. Okay. Now I go to the next question, number 17. You see here it is a x equal to 8 cos t plus t sin t and y equal to a within bracket t sin t minus t cos t. This is a parametric function. You have to find out d2y dx2. Here the method of parametric function differentiation is a little bit different, so be careful when I do the solution. Listen it properly, okay, see it properly. So first process is same, that is dy dx you have to find by using parametric form, because x and y are related via t. Okay, so parameter is t. X is here written, then ddt of x, that is equal to a constant ddt of cos t, ddt of plus ddt of t cos t sin t. Ddt of cos t is minus sin t. Here I have to use u into v rule. U, that is t, ddt of sin t is cos t sin t, and ddt of t is equal to 1. Here minus sin t and plus sin t will be cancelled out. What is left? At cos t will be there. Then y I have written, and that take derivative with respect to t. A ddt of sin t, here I have used u into v rule, minus is there, so minus ddt of cos t minus cos t ddt of t. Sin t derivative is cos t, a keep it as it is, cos t derivative is minus sin t, so it become positive, minus cos t into ddt of t is 1. This is cancelled out, so 80 sin t will be there. Okay, so we have got the value of dx dt and dy dt, so I can write down dy dx. So what is dy dx? dy dx is dy dt divided by dx dt. Put the values 80 sin t, 80 cos t. This is cancelled out, so 10 t will be left. Now you see your d2y dxt is, here you cannot do directly d2y, here you cannot do d2x dt2 and d2y dt2. That is not the procedure. To get d2y dx2, you have to take the derivative of dy dx. So I have taken ddx of dy dx. Now put ddx of dy dx is 10t. Got it? So dy dx first you get, then you this is very important, that's why I have just put here star marks. Okay, so 10t. Now we have to think it as x, then derivative is 10 t derivative is x square t. As you have considered t as x, so take derivative of t with respect to x, ddx of t. Then put the value of dt dx. dt dx is, we have got it already. We have got already dx dt, not dt dx. So take the reciprocal, that is 1 by 80 cos t. So I just substitute, this is equal to 1 by 80 cos t. So the answer is 1 by 80 cos t. If I bring to the numerator, it becomes sec t. So the result is equal to sec q t. So today I stop here. The next solutions I will give in the next videos. Okay, thank you.